Okay, Assalamualaikum. My name is Daniel Syafiq bin Muhammad Rosman. My matrix number is B0819102114.
And my name is Muhammad Afiq bin Ahmad Fauzi. My matrix number is B0819100063.
So today we're gonna present to you about lab 6. So lab 6 we introduced by DC motor, and also we're gonna present you some of the simulation, and we will show you the simulation and also some of the coding that we will explain to you how the function and how it works. So let's get it on. Okay, for part 1, lab 6 is about we are doing some simulation DC motor. So we have observed it. So the DC motor will rotate in the forward direction, which our motor will rotate on our clockwise, and when we push the button, the DC motor slowly stop and eventually rotate in the different direction, so in the reverse direction. So it's like it's reverse, it's going to the direction anti-clockwise. So let's run this simulation. So as you can see, the DC motor is running in the forward direction, clockwise, and when we push this button that's connected with the pin 7, we push this button and it slowly want to stop, and then it eventually slowly rotate in reverse direction, which means it's rotate in reverse direction lah. Okay, for exercise 1, we modified program in figure 2. So this is figure 2. So that switch 1 become a start and stop switch. So if the switch 1, we turn on the switch 1, the DC motor will run, and if we press again the switch 1, the switch motor will stop. So the speed of the motor can be adjusted with the variable resistor lah. So motor only can be rotate in one direction only. So for this one, we're gonna see that if we for this one, I have changed a little bit by using this old circuit, switching this button to switch, so it can be turned on and off. So let's run this simulation on. So if we press this button, turn on the switch, so the motor will run and rotate in one direction only. So it rotate at clockwise. So if I adjust this resistor variable, the speed will increase. And if I turn down this variable resistor, the speed will decrease a little bit. So it says that if we press again the switch 1, it will stop the motor. So if I turn off the switch and we get even closer, it will slowly the motor will slowly stop. It will slowly decrease the speed and eventually it will stop. Okay, this is the part 2, lab 6. So this part 2 will be observed that if we adjust the variable resistor, the angle of the motor DC motor will change, and also it will show us how many volt that we use when we adjust this variable. So let's turn on this simulation so that for first one we're gonna make that the variable resistor is 0%. So 0% is 0 volt. So the degree on the motor is DC motor is 1.63 degree. So if we adjust it a little bit more, so for example we take like 50% at resistor variable, so the volt will get 2.5 volt. The volt will show that 2.5 volt, and we will get the angle for the DC motor is 91 or 92 degree. Okay. So we're gonna fill the table below. So for voltage 4.5, ADC value is like that. So if we have this 2.5 volts, 2.5 volt, right? So this is 2.5 volt, and the motor angle that we get is we take like 92.5 at 92.6 degree. So for 1.2 volt, we adjust this variable to get the 1.2 volt. Okay. Until we get 1.2 volt. Okay, 1.2 volt. So the motor angle we will get is 44.8 motor angle. So to calculate the ADC value and also the motor angle calculation, we must use this formula. ADC value is equal to V in times 1024 divided by variable ref, Vref. So 2.5 V in what the voltage that we get, divided by 1024 times 1024 divided by 5, and we can get the ADC value 512. So the motor angle we get is 92.6. So the motor angle calculation is, we use this formula, 2.5 divided by 5 times 180. We can get it 90 degree. So for voltage 1.2 volt, for ADC value we will use the same formula. So 1.2 times 1024 divided by 5 is equal to 245.76. So motor angle we can get 44.8. For motor angle calculation, we will use the same 1.2 divided by 5 times 180, and we can get 43.2. Okay, this is the lab 6 exercise 2. Okay, we by using servo-h.h library, write a program code that rotate the servo motor based on potentiometer. So this is potentiometer. This is the potentiometer. This is the variable. So the operation similar with the program code of figure 3. So let's see the figure 3. So the figure 3, where is the figure 3? Okay, we're using the same circuit, and then we use the same coding, but we must add some hashtag include servo.h in our coding, and also we're using this PWM servo. So is we include this integer servo data pin at pin 7, and we set the pin mode servo data pin as output. So as a input, we set this ADC value E5 as an input, and also we write the digital write servo data pin as high, and also digital write servo data pin as low. So we run this simulation. So right now, if I adjust this register variable potentiometer, it will automatically the output will move when we adjust this potentiometer. If we adjust it like 40 42%, we can get the voltage like 2.1 voltage, and we can get like 77 or 78.2 something. So that's all.
Okay, now let's move to the part 3 of this lab, that is simulation on stepper motor. Alright, first one, we need to use Proteus to create this circuit. So it will be like this. And then for the second step, open the Arduino and then write a program code as in figure 7. Okay, so for in figure 7, like this one. So we just copy the code like this, and then so we paste the program code into the Proteus. So from this code, we first verify it. Okay, then we export the compiled binary. Okay, so we choose the hex file for part 3, and then we simulate it. And so for the observation for this second step, we have seen that with default step angle, the stepper motor run in reverse direction in 90 degrees for every sequence, like this. Okay. So for the next step, double click the stepper motor and change the step angle to 10. Alright, so first we stop first, then we click the stepper motor and change the step angle to 10. Okay. Alright, so then we run back this simulation. So we will see what happened. So for this observation, we see that the stepper motor run in reverse direction in 10 degrees for every sequence after we change the step angle input to 10. Right? Like this. Okay. Okay, then for the exercise 3, modify a program code in figure 10 such that the stepper motor rotate in reverse direction. Okay, so for doing this, basically for from this to until this code, it is the same like before, but we change the sequence here, negative negative, while before this it is positive positive. So if we change the negatives symbol, it will rotate the stepper motor in reverse direction. Okay, and then for the sequence equal to 4, we also change sequence equal to equal negative 4, right? So that's how we change this code. So we look for what happen if we insert this code into the project. So first of all, we compile it first, then export compiled binary. Okay, then we insert back into this Arduino Uno the exercise. So now it will in reverse direction. Like this. Okay, so that's all for this lab. Thank you.